Okay, this is kind of our lecture video 1B. I've had an intro video that I've put up on the screen and previously, or put up on Blackboard for you to look at just as kind of an introduction, and I'm going to expand on it a little bit here for our first week's lecture series. CIE 101 Civil Engineering Graphics, and this class is going to be, again, a little bit different than it's been taught in the past, in that I'm going to focus a little bit more on the graphics portion and possibly a little bit less on the building construction, even though that's something that will be integrated into the class as we go. So my contact is on first class. I also have a phone and a book if you need to contact me by phone, but generally an email to me will get a response fairly quickly. My main office is in 118 Service Building at the Facilities Management site, and that is 2 buildings down from the credit union. I'm sure most of you know where the credit union is, so just come down to the 1-story brick office building if you have some issues. We will have a couple TAs. I don't have the names exactly yet, but they should be on board, and we'll introduce those when they come on. I want to review the syllabus. You can find this on your site. This should show up as soon as you're logged in. So I'm gonna flip over to that right now, and I'll continue recording this. I'm just gonna go to my Blackboard site. I've logged in. It's under www.courses.maine.edu. You should see your CET 101 2014. And if you pull that up, you should see on your left-hand side a syllabus. And some of this hasn't been updated yet, but I am working on it. Yep, there's syllabus and schedule. So let's look at the syllabus. Again, same thing. I am an adjunct instructor for the Department of Civil Engineering. I've done this class once before, back when we used to do it with MicroStation. We're now using AutoCAD 2014. Some of this stuff is hasn't been updated. For instance, this material here is not going to be used, but I'll get that updated later on before the actual class starts, so that'll be in there. Classes are Mondays from 3:10 to 5 for one group in 318 Boardman, 5:10 to 7 p.m. on Monday, 318 Boardman for group number 2, and we also have a lab session on Wednesdays 3:10 to 5 in 318 Boardman. In addition, there will be an open lab on Wednesdays from 5:10 to 7 in 318 Boardman, in which either I will be there, one of the TAs, normally it would be just me, sorry about that, and I'll be there to help. If you have any questions, problems with the assignments, any issues, you can come by and we can get those taken care of. In addition, we can set up a time. I'll try to get some regular office hours in Boardman, and I'll let you know about those when they become available. I don't have an office in there just yet, but if I do, I'll let you know. I would like to say at this point, what I did last semester was a Tuesday and Thursdays. I had open offices from 4 to 5 on Tuesdays and Thursdays in a space in Boardman. Now, if 318 classroom is available, I'll take it. Course objectives, we're going to talk about basically trying to maintain a civil engineering atmosphere, looking at buildings and roads and site work and heavy earthwork and bridges, which basically covers pretty much everything with the exception of some mechanical engineering. So we're going to cover all the aspects. Civil engineers. How do I get this to stop doing? Don't show this message again. There, maybe that'll work. So we're going to look at how we organize ourselves for the engineering process for projects, and how we use our standards so that everybody's kind of working off the same page and we have a better handle at making this work. Now, let me go back up here to our textbooks. We're going to be using textbook 1 for the first part of the semester. Will be Introduction to AutoCAD 2014 for civil engineering applications. During the second half of the semester, we're going to be looking at Autodesk Revit Architecture 2014 Fundamentals, the textbook, which is a BIM product, or a BIM we're going to be talking building information modeling is BIM. It's more of a technique as opposed to a specific piece of software, but it basically gets us into that fourth dimension, fifth dimension, sixth dimension in CAD, where we can start putting some intelligence into our models and drawings, and that is a 3D modeling package. We have a construction drawings lab package for Student Recreation Center and MDOT Old Town Milford Bridge. That is just a drawing package of some drawings that we use in the class for reading and identifications. In addition to drawings, we're also going to be looking at specifications and how they're put together. We're going to need some engineering and architectural scales available at the bookstore. They're a 3-sided scale or ruler, and they're generally fairly inexpensive. The AutoCAD software is a free download, and I'll show you where to go to locate that. It may be part of this PowerPoint presentation. If not, I'll slip over there before we finish up today. I'm going to give you some reading assignments on a weekly basis. So this week, during the lab portion, we'll be assigning the first 2 chapters of the Introduction to AutoCAD 2014, and I'll put together some other exercises that will show up on your Blackboard. We do have some quizzes in Blackboard, LSQs, little short quizzes. I think that's what that stands for. This is from Will Mannion's work, so I'll be working on some of those. I'll be changing them up so they're a little in past semesters. The book that was used for this class was Building Construction by Yano. I've used that book in the past. It's basically not a CAD textbook. It doesn't teach you CAD. It teaches you building construction techniques and terminologies, and we'll still be utilizing some of that information, but it's just I really want to make this a graphics, teach you how to use the graphics, use your layers and your levels and your pen widths and make things output and look professional, and that will be a major emphasis of this class, in addition to trying to get some building information modeling aspects into the class also. Currently our drawing assignments, I'm guessing maybe around 12, about 30% of your grade. Online lecture videos, it'll maybe a quiz afterwards, 15% of the grade. Lab worksheets, 20%. Exams, I usually do a midterm and a final, 35%. And chances are the majority of this exam process will be a drawing assignment. So you're going to be putting together your title block and doing a drawing from an exercise. So it's important that you become as proficient as possible with the software, which means you have to use it. The TAs will be responsible for collecting the homework, and if you have any issues, we do have disability services. If people need additional time, you'll need to check in with Ann Smith over in Disability Services to make sure that they get a notification to me. As far as attendance, we do have 3 regular labs plus the extra lab on Wednesdays from 5:10. If for some reason you cannot make a specific class, feel free to show up at one of the other lab sessions. I'm going to try to keep these going as unified as possible, so if you miss one, that doesn't mean that I want to see 92 people show up on the Monday 3:10 to 5 class or the Wednesday 3:10 to 5 class, because you don't want to be in the 5 to 7 class. That's unfortunate, but you're really going to need to have an excuse to show up. Otherwise, show up at your regular scheduled lab, because we're already kind of crowded in this room. If you're sitting in the room now, or if you've been in 318 Boardman, you'll notice the tables are set up a little differently. It is designed so that I can work with you on the software, or the TA can work with you with the software without climbing over somebody to get to you. So it's a little different. We do have, everybody will be required to bring in a laptop. The software is available for Macs, I believe, from Autodesk. Even though Macs are generally a little bit slower when you're trying to run CAD programs with them. So just be aware of that. Let's get back to our PowerPoint. Oops. Don't want to edit it, I just want to slideshow. There we go, sorry. So we'll get back in here. These video lectures I'll be updating them once a week. We'll review the schedule during the labs, but you can generally expect to find a YouTube video of 45 to an hour or so for each class that you should view. You can do it on your smartphone, but some of the illustrations may be a little hard to read. One of the first things we're going to do is set up our title block that will be used throughout the semester. We'll probably do an 8.5 by 11 and maybe an 11 by 17 title block. It's important that we be as lazy as possible and still look productive. So we're not going to create a new title block for every assignment that we do. We're going to use a standard title block. We're going to work with some annotation text so that when it comes up, we just update the title and the scale, and the some of the stuff will be automatically updated. So it's important that we get this assigned first, and it's kind of a good exercise to work with initially, because we're working with a lot of straight lines and offsets and copies and putting on text and doing those things that are kind of basic, but it's going to give us something that we can use productively after the fact. So generally with my graphics classes, I try to get a title block designed as close to the beginning of the semester as possible, because it's something we'll use over and over and over again. It's not going to be really it's going to have some of this information, but not everything. So we'll get that taken care of first. Within the American Institute of Architects, we have sheet labeling abbreviations, and those are pretty standard. I think I've added some stuff in here. When we do a sheet, if it's architectural, it's going to have a designation of A, C for civil, E for electrical, F for fire protection, G for general, H for hazardous materials, I for interiors, this could be furniture, L for landscapes, and I've seen this used as in FF and E, but interiors would generally be furniture, landscaping, mechanical, P for plumbing, Q for equipment. These would be like fume hoods, something like that, going into a space. R for resource, S for structural, T for telecommunications, X for other disciplines, and Z for contractor shop drawings. All this means is when I look at a stack of drawings like this, the sheet number is always in the lower right corner. So if they're stapled on this end or bound on this end, we can flip through these, and generally most of the architecturals would be in the front. The cover sheet may be under general, so it may be a G100. This might be a basement plan. If it says A100 would generally be a basement. A101 would be a first floor plan. A102, second floor plan. A103, third floor plan, and so on. When we get to the electrical, we're going to see the same floor plan, but it would be an E100 for the basement, and that would have all of the electrical details on top of that floor plan. So we get back to that multiple sheet aspect. In addition, there are some numbering sequences. This one uses, the AIA recommends A1.01 architectural floor plan, first floor, sheet number 1. A102 architectural floor plan, second floor, sheet 2. I don't know that we would necessarily, normally what I see in architectural plans be A101 or A100, 102, 103. They don't break it down quite as fine as this, but you do see a recommendation by American Institute of Architects that 0.01 to 0.99 is general information. 1.01 to 1.99 floor plans, 2.01 elevations, 3.01 sections, 4.01 large scale plans, 5.01 details. So you might not see the decimal, it might be just 101 to 199. And when you see the A200s, that would probably be your elevation sheets. A300s, your sections. So I'm not necessarily sure you need the decimal place in there, but some kind of configuration or standard like this is understandable no matter what, so that you can identify these drawing files without having to open up the entire set. You can kind of thumb through that corner and find what you're looking for. If I was looking for a structural set, I'd be looking under the S's, and all those files would be in one group within the drawing set. Cover sheets, and this is generally the typical set. This would be for residential plans, so it doesn't have everything that we'd see in a commercial, but you start with a cover sheet, might be a presentational drawing, site plans, exterior elevations, floor plans, electrical, structural, plumbing fixtures, foundation plans, roof plans, sections, and details. And that's great. When you get into commercial, we generally see more in the floor plans up front. The elevations would be next. So there are some standards, but this just happened to be something I pulled off the web for a residential set of plans. If we open up our plan set from the booklet that you picked up at the bookstore on 11 by 17 paper, this is a section from, or a plan view with a area from that plan for the first floor plan of the recreation center. You probably recognize this as the pool area. Here's the handicap accessible wheelchair entrance into the pool. We've got our whirlpool here for the volleyball and sports and whatever else it is they do in there. We can see the hot tub over here, the kiddie pool on the right side with the fountains, and then we got our 2-lane swimming. We see some information in here on the floor plans, and I'm not sure if I can, but this diamond shape, 1, 2, 3, and 4, this indicates elevation. So on page A601, I'm not sure if you have that in your package, there's an elevation 2 which looks in this direction at that pool, and you'll be able to see what it looks like looking out through that pool. Elevation 3 from this spot would be looking in this direction, elevation 4 in this direction, and elevation 1 would be looking to the west out through the glass wall towards the tennis courts. So that's one aspect of this. This is the nanatorium. It's room 159. They give some references, some dimensions. There's some details here. You can see this detail here is on A426, which is detail, looks like detail 3. Lists some dimensions from the outside wall. We have a finished floor elevation, 136 feet 0 inches for this finished floor. So we can see that from the floor plan we're referencing other areas of the drawing set with these numbers. So you can see a door number up here that generally reflects the actual room number also. Try to keep those things consistent. Get a set of stairs that walks down into the deeper end of the pool from the shallow end. So everything's kind of laid out. It's recognizable. We can see what things are going on here. One of the sections, this is on your sheet S502, which is your structural set. We can see some information on this drawing that includes identifications. This is a cross section through the foundation, so we can see some support drainage material. This is generally crushed stone that's been compacted. We can see a drain tile here, just a piece of drain pipe. We know that our footing is 1 foot thick or 1 foot high. The width is 2 feet. We have 2 pieces of number 5 continuous, and they just say number 5, so you assume that you know that it's rebar that they're talking about. This is the steel reinforcing that goes into the concrete. We know that rebar, the number of the rebar is the number of 1/8 inches. So a number 5 rebar, the diameter is in 1/8 of an inch, would be 5/8 inch diameter reinforcing steel, continuous, meaning I've got 2 lines of rebar running continuously around this entire footing. We have number 5s at 18 inches on center each face. So in other words, they're going to go vertical 18 inches on center and horizontal 18 inches on center on both sides of the foundation wall. And they'll be, the dimension is 6 inches, looks like, from the center line of the wall to the outside of the insulation. Again, we have this hatching refers to compacted structural fill. We have that compacted support drainage. We have a layer of insulation underneath this edge of the slab. We have insulation behind this piece of precast concrete panel, and then this is a precast insulated wall panel that goes up on the top. There's our concrete slab on grade with reinforcing, and we have an isolation joint right along the edge that allows us to allow some movement without cracking the concrete, because as we know as civil engineers, concrete is brittle and it will expand and contract, and if it doesn't have anything to move against, it will crack in some very ugly conditions. Elevations are shown here, and you can see what they're doing is telling us to look at the plan to determine the elevation, because this section is fine, but in different areas may be different elevations. So it's saying look at the plan. Top of slab, top of footing, top of shelf. Right here, this is the shelf on the foundation. Top of grade, this is your normal grade on the outside. So again, that's one that's going to change as it goes around the building. And the top of wall, see plan. This is the top of the foundation wall. All of that information we can look at, and if we looked at number 4 from where this was taken, it would be a 4 in a circle with a S502 underneath it. On that plan, we'd see exactly where this was taken from. Here we have an elevation 3 inside the gymnasium, and this is on the end of the building that has the roller hockey rink built into it with the doors. So this would be on the north end of the building. We can see the lights hanging, the basketball hoops, the bracing. Up here we see it says light fixture size, ceiling plans typical. It means you got to go look at the ceiling plans. Painted high impact gypsum wallboard typical. Bottom of low return duct at 13 feet above finished floor, which is right here. You can see the running track, that portion of the running track that runs along the side of the rink below is shown right here. And we see a detail, 19 on sheet A, 801. So if you want to see what this open web steel joist looks like close up, you can look at that sheet. I'm not sure if it's in your package, but I have the complete set, so I will bring that stuff in at some point and we'll take a look at it. This is a cross section through the running track above the gymnasium, and again, this is on sheet S517. Gives us a top of, TOS is top of steel, so this is the actual structural steel. On top of that, it has a metal deck, and then there's poured concrete on top of that with a there's another finished floor, which is the track surface itself. and we see part of the railing. So this is just from the structural drawings, the framing layout, and that track is suspended from cables above, steel, or not cables, but steel rods. So it's actually suspended from the roof, and so it kind of floats out there above the basketball courts. That's just some of the things we'll be looking at in those drawings. Now, within civil engineering field, we need to look at a lot of different regulatory compliance programs. One is the U.S. Green Building Council LEED program. LEED is Leadership in Energy and Environmental Design. And I have mixed emotions about this. I think our previous instructor was quite high on it, and it's an important thing. But what I don't really, and this is just a personal opinion, being a project manager with facilities, is I don't really care for the fact that it is administered by the American Institute of Architects. That said, it does have a lot of different things that are important in construction. Some areas of the country it doesn't work as well as others, because certain things within LEEDS certification are tough to get when you live out in the country. So this is a picture of the recreation center, which is LEED Silver. And how did it get LEED Silver certification? This is a plaque that you'll see on the outside of the building. They do it by including relationships to bus stops, putting in bike stands, using low water fixtures, daylighting from the outside, getting enough natural light into the building, high energy efficient fixtures, including mechanical equipment, solar orientation, low water landscaping, electric car plug-ins. There are a number of things that you can get get your LEED certification points from, and it runs, again, how much energy is the building using, how much water in the building, how much raw materials. And one of the things with LEED certification is during the construction process, how much of the material being put into the building is recyclable. We look at the entire life cycle of the building, not just building it, designing it and building it and occupying it, but we look at what's going to happen when the lifespan of that building is over and we need to tear it down and rebuild it. How much of that material that we're going to be taking down can be recycled into other products rather than put into a landfill, and that is something that is big on the LEEDS certification. So, as a designer, why should you consider a green building? From the AIA standpoint, the only way to be a LEED certified is to hire a LEED certified architect, which is kind of one of those other little sticking points that I have. But you can see here's just some project profiles from some different buildings, that how they got their LEED certification. And we don't need to go through all this material. I will post it on the Blackboard site at some point before the class starts, and so you'll have it to look at yourself. You can see 90% of demolition debris recycled, 20% energy cost savings, 80% of wood is FSC certified, which is the Forest Council's certified forest, meaning that the lumber, the structural lumber that was put into this building came from a lumber mill that purchased its trees from a landowner that is replanting 2 trees for every one they harvest. So to become a certified forest tree, you need to make sure that you don't have people out there just stripping the land. So again, common sense, it makes sense. They may pay a little bit more up front for a certified forest product. Almost everybody is certified now. So those things are important. Manufacturers are looking and making sure that their paints are low VOC, this volatile organic compounds, because they don't want to make people sick after the fact. And this not only is in paints, but it's in carpeting. Those low VOCs are something that are fairly important. It didn't seem to be a problem 30 years ago, but now people are becoming more sensitive to this these smells, and whether it's real or imagined, people still, it's an important thing to keep people within the workplace healthy. So you'll notice on that previous one also, more than 50% of material were manufactured within 500 miles, which again puts Maine kind of in a bad situation because we don't have that many manufacturing facilities, so we have to bring stuff in. So it's difficult to get those points for LEED certification when we have so few resources around. If we look at, here's another one, they look at energy usage, waste material. And what you'll notice is if you see a building being constructed, you'll see dumpsters outside. And if they're trying to get LEED certification, each dumpster is labeled metal, wood, paper and cardboard. Anything that's recyclable goes into its own bin so that they can keep track of it. And they actually weigh the material before it goes out in order to get those LEEDS points. Another one, you can again read through this stuff yourself. Here's some residential type structure, could be a doctor's office. Solar power gets points. Orientation. They talk about, here's the Nationals Park, which is a LEED certified stadium, has bike valet service on game day. So if you bring your bike, you can have somebody park it for you. Easy access to subway and the bus. 6,300 square feet of green roof. And what a green roof is rather than asphalt or vinyl or some type of polymer, they actually may have that underneath, but on top they have vegetation on the roof, which allows the roof to absorb water before it runs off during a heavy storm. One of the big things with LEED certification, and something that's very important nowadays, and especially on campus here, is stormwater management. If we have two spaces that are both 4 acres exactly, and one is grass and vegetated and the other one is asphalt, and we have a torrential rainstorm, which one's going to run off first into the Stillwater River? It would be, of course, the pavement. So if that happens, all of the contaminants that are on that parking lot, oil and grease and paper and chewing gum and whatever else people have dumped or thrown out, gets washed straight into the river. Whereas if it falls on that green space, it has time to get itself absorbed into the ground, to filter itself, to clean itself up, and just delay the amount of water that goes into the stream at any one event. So keeping and maintaining a certain amount of green space within your pervious or what we call pervious and non-pervious space is important in the construction process, and we have to deal with the Department of Environmental Protection to make sure that we are licensed. You have to get a permit now to build anything on campus to make sure that we balance out our wastewater treatment or stormwater treatment. Green building, 5 areas. And where this works: site planning, water management, energy, material use, indoor environmental quality. To be certified in LEEDS, 40 to 49 points will get you certified. If you want to be silver, it's 50 to 59, gold is 60 to 79, and in platinum you'd be 80 to 110 points to be platinum certified. Pretty hard to get, especially up in this area. This is an example of the site information that you would get points, and these points. So brownfield redevelopment, you get a point. What is a brownfield redevelopment? That would be taking an old factory site that was contaminated with, PCBs or other types of pollutants, and cleaning it up and redeveloping it into a new site. We have that happen a lot in these places where we're tearing out old factories and developing them and cleaning them up, taking out the asbestos and the lead paint and the PCBs, getting rid of all that stuff. You get a point for brownfield redevelopment. making it work. A lot of times communities will also give you tax incentives for those types of things. Alternative transportation parking capacity. Putting in your bike racks or bike storage and changing rooms are up here. So if you ride your bike to the facility, they have a bike storage, and you also have a place to go in and change your bike shorts into your office work or your whatever you're doing, so that you're not wearing your bike shorts all day to work. So you get a point for that. Alternate transportation, low emitting and fuel efficient vehicles. If you look over at the not the advanced, but the AEWC, I'm not sure what they call themselves now, but the wind blade testing facility, they actually have electric car charging posts out in front of one of the parking areas, and so if you have an electric car, you can go over there and plug it in. We haven't really figured out how to recover the cost of that, but it's a cheap way to get your car charged. So those types of things are also there. Light pollution reduction. We want good light, safe light, but we don't want to pollute it, apparently. So you get a point if you're reducing the light pollution. We want it focused in one particular area, but we don't want to spread it out where it's going to just make the whole place too bright. So that's worth a point. Water efficiency, you can see using things like water efficient landscaping, water use reduction. They have things out there like waterless urinals. We don't use them on campus because they don't get maintained as well, and people dump stuff in them they shouldn't, so we kind of get away from that point. But innovative wastewater technologies can be incorporated into the system. Reuse of gray water, for instance, for they do things on cruise ships where if you go in and wash your hands in the sink, they may save that water to flush a toilet. So they filter it a little bit, and then when you flush the toilet, it would use the water that you use to wash your hands as a recycling. So anything you can do to kind of take care of that that gray water, so it doesn't just go into the sewer system, that it actually can be reused in another event before it goes into the sewer system is helpful. More energy and atmosphere, optimized for energy use. This would be solar panels, that type of thing, green power. Materials and resources, how much of it is construction waste is being recycled, are worth points. Indoor environmental, this is the VOCs, having a smoking policy, light controls, so that if you walk out of the room 10 minutes later, the lights go off by themselves. If they don't get overridden, most of these controlling of light systems tend to get overridden because people don't move fast enough around here, and the lights go off automatically, so it becomes kind of a difficult thing to control, and if they get overridden, then you're not worth anything. Fortunately, right now, there's no, your LEEDS certification is based on the time of occupancy when it's occupied. What happens after that? They don't have LEED police that come out and rip the plaque off your building because you stopped using a certain function of the building. It's there. It's for your benefit at that point. So if you can use it, good. More points in design and regional priority credits. Whoops. Guess I hit the end of the slideshow. And I left this one in, the end. What do we need to do? Well, this is important, but LEED is just one of the many industry organizations that helps us stay focused on what we need to do. Whether it's, if I was building a building myself, I'd want to make sure that that it's built to the highest energy efficiency possible, but I don't know that I need, there's a cost involved in getting LEED certified. An architectural firm will generally charge anywhere from $20,000 to $30,000 in addition to their design fees to formally maintain and document the LEEDS certification. On a side note, when Governor Baldacci was in office, he made it a specific requirement that any money being spent on public institution buildings construction was required to be LEED certified. So we were forced to do this, and in some cases it's very beneficial. In other cases it's not so much. When Governor LePage came into office, he kind of changed the rule and said, do it whenever it's practical, which is a good idea. I'm not busting up on either one of them, but being forced to do it can be expensive when you don't get the benefits out of it. And I think in common sense in today's age and energy costs and things like that, that we would try our best to do good construction. Whether you have a plaque on the wall when you're done or not, irregardless, you should be thinking about energy efficiency in design, and even in civil engineering. If you're doing bridges and roads, we look at the material we're putting down and how recyclable that material is as we do it. So it's important to maintain that. So we'll be talking more about other organizations from NFPA, National Fire Protection, the American Institute of Architects. We'll be back with them a little bit later. We've got CSI, the Construction Specifications Institutes, looking at our layering options for our drawings. But as we design and work through things, we need to really think about how we're putting our buildings together. And our next lecture that I'll put on here has to do with the delivery method for our construction. The delivery method involves how we obtain our drawings and specifications, who does the design work, when does the contractor come into play, how do we bid the project out. Those are all things that there are multiple ways of doing that in the industry today, whether you're a university or a private business. The bid process is tedious and complicated, and we will talk about that at the next video opportunity.